All right, so in class when we did, we barely started the notes for 3.3 part 3 the other day, and we did 1, 2, and 3 together, and I know there's a video of 1 and 2 if you were gone, and then 3 you can try and check with that answer key, but we did do that one already. So the whole idea of this is you're not going to be able to initially start right away with like algebra techniques, like inverse operations or square root both sides. And factoring won't be an option either. So one of the first things that we've said that we could do when we were working on like verifying identities, our little yellow sheet, was, hey, if we can write these in terms of sine or cosine, that's usually initially a good place to start. So if I write these with its equivalent using those identities, what happens is I now am able to add these two together. Now, this is nothing is being squared right now, so I can't go to my Pythag identities. So once they have a same denominator, we love fractions that have the same denominator because we can go ahead and add the numerator. So I just added those, and we're good, okay? Now you might be thinking, well, I have no idea how this is going to help me. Well, what we can now do is if I then think to myself, what could I do from here without making it even crazier? One of the things that we've worked on a lot this year is getting like variables out of the denominator. So if I multiply both sides by the sine of x, that helps me get 1 plus cosine of x equals sine of x. Now, a mistake I saw a lot is that people are trying to replace this with sine squared. This is not squared. So we do not have anything right now. If I move this over, I don't have anything as far as an identity. So we used identities initially, but we've really been using algebra. And so one of the things that people forget about from Algebra 2 is that you're going to actually, to help us, believe it or not, because remember, in order to solve this either needs to be a sine, so that everything is in terms of sine, or this needs to be cosine. And one of the ways that we can do that is I'm going to square both sides. And I'm allowed to do that because I am keeping it balanced. So I'm doing the same thing. So what that means is this actually, and I'm going to come out over here, we're just going to FOIL this. So over here, off to the side, remember, this means 1 plus the cosine of x times 1 plus the cosine of x. Okay? So when you multiply that out and simplify it, you get 1 plus 2 cosine of x plus cosine squared of x equals sine squared of x. And remember, these are equivalent. We just write it like this in trig. Now, I can leave this alone for a minute. And if I'm looking at this, I'm like, yes, because this side right now, I can use a Pythag identity. So sine squared of x, I can replace that with 1 minus cos squared of x. And you might be asking, well, how is that going to help me? Well, we're really kind of back to where we were maybe in Notes 3.3 Part 2, where if I move everything over here, I wonder if this would factor. So let's subtract 1, and let's add this cosine squared x. Now, as I combine like terms, so we have a 0 on the right, I'm going to put this in order. And what I mean is I'm going to go from high exponent to low. So we have 2 cosine squared of x plus 2 cosine of x, and these 1 minus 1's cancel. All right, well, we have a GCF. So with our GCF, if we factor out a 2 cosine of x, we're left with cosine of x plus 1 equals 0. And now it's perfect because we can use that zero product property. Well, we can divide by 2, and so obviously 2 can't equal 0. So when will the cosine of x equal 0, or when will the cosine of x plus 1 equal 0? So if I get cosine of x by itself, ultimately we have the two equations that you need to solve. So when will the cosine of x 0? So remember, you're looking around that coordinate plane, knowing that unit circle. So this would be at pi over 2 and 3 pi over 2. And when will the cosine of this angle measure equal -1? That will be at pi. So we officially have 3 answers to number 4. Okay? So that, along with the 2 that we did in the warm-up, should help give you at least, I think that's 6 now, examples of, yes, they're not all identical. So remember, the hard part of all of this is getting started. And if you fail the first time, that's okay, but you might need to just try another way or another identity. But please make sure you're doing things that are allowed, as in a sine of x to the 4th power cannot be combined with a sine x to the 2nd power, just like you cannot add x to the 4th. So I've had people that are trying to add those up, and you cannot do that. So if you can't do that, then you can't add these. So I think there's some interesting things that are going on, and that kind of dates back to algebra, okay? Now on this bottom, I'm going to go a little bit faster through this. Initially, I think we've done some stuff in class, but I'm going to pull out my graphing calculator and show you a little bit. So if you want to graph this, you can. Most of you probably could graph this parent function in your sleep. But I will tell you, when you're looking for the x-intercepts, what I'm trying to do here is correlate what is this correlation. And all that is when you find the x-intercepts of any type of equation, you're trying to figure out where's the y value, 0. And so this is what we've been doing this whole chapter. And I want you to just make that connection, is that it builds from last chapter. So the x-intercepts are when is the cosine. So you literally could solve this right now. And we actually did it up here, so this is perfect. The cosine of x is at pi over 2 and 3 pi over 2. So the x-intercepts are pi over 2, 0, and 3 pi over 2, 0. And if you don't remember what that cosine graph looks like, pull out that calculator. And when I hit graph, and I have radian mode, and I went from 0 to 2 pi, and I went from 3, I think, to -3 to make it look like what's on your paper. But here's those x-intercepts. And then if we kind of draw this, remember, it goes from 1, and it's going to dip and come back up. So that's why we've never gotten an answer over here that's higher than 1 or lower than -1. So I'm just trying to correlate all this work that we've been doing, especially like up here, with what it means. Now, I think this was probably too much at the time. I didn't know if we'd need it, but let's just go to C. Let's just bypass this one. For C, if you're going to graph this, the best thing to do is to pull out that calculator right now, because I know it's been a long time since we've graphed. But when you type in the cosine, make sure that you're putting 1 divided by 2 in its own set of parentheses, and then hitting x. So this time it's red. I should have used red and color coordinated on my paper. But it appears that there's only 1, and we can hit trace. You just go to the up arrow, and it's not going to give you this exact, but that is your calculator's way of rounding. I don't know if you see that. It's scientific notation. It's like 0.0000000. So this is actually, it's a true statement, that if you were going to do when does this function, for what value would I plug in for x as far as angle measure, that's going to occur when we have x equals pi. So I think you can tell from your graphing calculator. Now what's interesting is this graph also comes here, but then it ends out here. So it still has that same 1 to -1, but it's only crossing the x-axis once. And I know it's really hard on your calculator to kind of see, but not everything is always going to come out to be these perfect pies and increments. And we talked about this in class of 90 or 45 or 30 or 60. And so the two problems I had you do after our quiz really will help us lead into the next problem, okay? So if you want to go ahead and turn it over, let's take a look at example 6. Now, what's great about example 6 is this is kind of twofold, is it says you can use your calculator, and we're going to find approximate. So as soon as you see that, that should be a red alarm sign going, oh, we're probably not going to get the sine of x equals a half or -1 or 0 or radical 3/2 that we've typically worked with on the unit circle. So let's go ahead and solve this, and I can tell you right now, we already have a sine and a sine, so that's good. So this is actually a problem we can solve by using just our algebra. So I'm going to subtract 7 sine of x from both sides, and that gives me -4 sine of x minus 2 equals -3. And then when we add 2, so I know some of you do a lot of this algebra in your head, which is fine. Oops, what am I doing? Sorry, that's -1. And then let's divide both sides by -4. So ultimately we're asking ourselves the sine of what angle measure, x, equals +1/4. Now, we're not done because we have to solve for x, but we all know that this is not typical, okay? So when we've been on our unit circle, it's really important to understand that we've been looking for, around this unit circle, when was the sine of x maybe a 1 or 0, and we had 30 and 45 and 60, and we knew those coordinates. This doesn't belong to one of those coordinates. So this is where we have to be careful about what are we doing. So because I gave you the interval in radians, I really want your answer in radians, but I think what I'm going to show you is going to help you. So in our warm-up the other day, we reviewed that if we can't do this in our head because of that unit circle, then what we did is, in order to get x by itself, and you can still do this even if you don't want to do it in your head, but that's why we haven't let you use a calculator. So if we take the inverse sine of both sides, we get x equals the inverse sine of 1/4. And that turns out to be, and you're going to see me round, let's round to the nearest hundredth, about 0.25. Now, I'm going to pull my calculator back. We want to make sure that you are in radian mode. So right now, I'm in radian mode. So I'm going to type in the inverse sine of 1/4, and that's where I got that around 0.25, okay? But what's going to confuse students is that this is 0.25 radians. And sometimes people are like, oh no, I don't remember what 1 degree is as a radian, and where does 0.25 fall according to other radians? So one trick I can tell you that has helped me is that if I go into this problem again and I go to degree mode, this just helps me slightly to give you a visual, and then I do this all over again. So once again, I'm going to go inverse sine of 1/4, but remember, this is going to pop out the degree. Oh, okay. So this is about 14.5 degrees. So I'm just going to put like a sidebar here that 0.25 radians is about 14.5 degrees. And the reason that I would do that is that I now can kind of draw this. I know what a 14, I know that might be bigger, but this is 0.25 radians, which is equivalent to about 14.5 degrees, okay? So what that does is that helps me find the other solutions, because I know that 14.5 is in quadrant 1. So one of our answers definitely is going to be in radians anyways, 0.25. Done. But remember, we have to see what do we need to do all the way around the unit circle. So I'm going to pause here and go to the next video.